So you have been learning about orbits, right? Now everybody understands, has an idea what an orbit is.
Yes.
Okay? Has a general idea what an orbit is.
It's a
How do you uniquely describe an orbit? That's what we are going to discuss. If you recall, what is the orbit equation?
R.
What is the orbit equation again?
R equals h squared divided by u times 1 over 1 plus e cosine theta.
So here, this is the orbit equation, okay? Now, this itself has at least 3 parameters which tell something about the orbit. Got it? What does this E tell you?
This is eccentricity.
What does it? Yes, it is eccentricity. But what does it tell you about the orbit?
The shape.
Shape of the orbit. Okay. Does it say something about the shape of the orbit? E. Right? E equal to 0. The shape is circle. That's what. Okay. This one, what did we say? H. The size of the orbit. Okay. So this H essentially is in this direction, right? If the orbit is like this, H is in this direction. H is always perpendicular to the plane of the orbit. The bigger this H, this size increases. Got it? That is that vector. What does this mu tell you?
Gravitation.
But what does it tell you about something about the orbit? What does this mu a parameter of? It's a gravitational parameter. What is the gravitational parameter of?
The center body.
The central body. Yes. So this is the gravitational parameter of the central body. Right? So there is always 2 bodies in the body. Okay. This is telling you something about the orbit, the path of the orbiting body. This is telling you something, the shape of the, again, the orbiting body or the orbit. This theta tells you where that orbiting body is at any given point of time. Right? This theta. So that's what we are going to see there. What you really need is to completely define an orbit, to completely identify an orbit. You need these 6 elements. Alright? We'll talk about that. You need the size of the orbit, you need the shape of the orbit, and you need the relative orientation of the orbit with respect to a known plane or a known coordinate system. And then you need the position of the orbiting body in an orbit at any given point of time. Got it? We'll talk about it. So A, E, that parameter is this. So look at this. First look at there are 2 planes here. I want you to recognize the 2 planes. What are the 2 planes here? Can you recognize the 2 planes? 2 planes. You understand what a plane is? Huh? What is a plane?
It's the axis.
Huh?
The axis. Yeah.
It's not an axis.
Not the axis, but area.
Huh?
The space between the 2 axes?
It's a grid. It's an area.
It's a surface. It's a surface. How do you mathematically define a plane?
Two X and Y. It's a measurement.
How do you define a plane? How do you define a line?
Take 2 perpendicular lines.
How do you define a line?
This is between 2 points.
The shortest, the distance between 2 points is a line, right?
Right.
How do you define a plane there. If there are 3 points, when you join those 3 points, at least 3 set of points, that will form a plane. And it's a circle. All your
They have to
definitions
be on the same, but they have to be all on the same plane, right?
The thing is, if you take any 3 points, it will always form a plane.
So it's just 3 now, right?
Huh?
Because if you add a fourth one, it could be
That has to be on the plane.
Yeah.
So minimum set of 3 points will form a plane. But 2 points will not form a plane. 1 will not form a plane. But at least 3 points will always form a plane. And as long as those 3 points, the relative distance between those 2 points is the same, the plane is not changing. It's a rigid plane. You know what a rigid plane is? What is the difference between a rigid plane and a flexible plane?
They change shape.
Yes. So if you take those 3 points, if the distance between them, relative distance between them is not changing, make sense? It's a rigid plane. Does it make sense?
Break it down.
Huh?
It's a break it down. I'm with you, but I'm trying to, I understand what you're saying. I'm trying to.
So you have 3 points. Take this. If these are the 3 points, okay. If I join these, this is my plane, right? This can be in any free space. These 3 points can be in any free space. It forms a plane, right? As long as the distance, the relative distance between these 2 points, these 3 points, is not changing, this plane is a
Rigid.
rigid plane. You get it?
Yes.
If it is changing, that's a flexible plane. Alright? Make sense? Very simple definition. So this plane, you see 3 planes there. Sorry, 2 planes there. What are those 2 planes? Can anybody tell me what are those 2 planes? It's actually pretty simple.
It's the orbital plane.
Yes. What is the other plane?
The equator. The plane.
Yes, exactly. So the first one is the equatorial plane. Do you see the equatorial plane there?
Yes. That's the great
That's
one.
This is the one.
That's the great one.
Which one is?
That's the great one.
The grey one is the equatorial plane. You understand what the equatorial plane is?
Yeah.
It's for the
It's the plane which passes through the
It cuts it out.
huh?
It cut. It separates the plane.
It slices the Earth into
Hemisphere.
2 hemispheres. And that's the equatorial plane. You see the orbital plane?
That's the
The hatched one, that's the orbital plane. Okay? These 2 planes, where do 2 lines intersect?
Where was that?
Where do 2 lines intersect? 2 lines intersect at a point. 2 planes intersect at
Axis.
a line.
Oh, yeah.
Always 2 planes will intersect at a line.
Oh.
You see that? Just like 2 lines intersect at a point, 2 planes will intersect at a line. You see that line of intersection?
Yes.
What is that line of intersection?
Line of nodes.
Yes. The line of nodes is the line of intersection of the orbital plane and the equatorial plane. You get it?
Yes.
Can an orbit exist without that line of nodes?
I want to say no, but
Maybe.
It cannot exist without the line of intersection.
So you need.
It has to be. What is at the center? So what is at the center there? What is this point? What do you know about this point? Yes, that is the focus. Keep in mind, that is not the center. That is what we have been discussing. That is the focus of
The orbit.
the orbit. Okay? So that is that focus. You get it?
Yes.
So that focus has to be there. So there cannot exist an orbit which will not have this line of nodes. You get it? By definition. It has to.
What if it's like the orbital plane is on the same plane as the equatorial
That's a good question. So the line of node is anywhere. That's a very good question. So then it may not exist. You're right. But practically speaking, that line of nodes will always. What I'm trying to get is, it will not, in the sense. So it cannot, if you are, this is your equatorial plane, okay? This cannot be your orbital plane.
So the line of nodes always includes the focus as one of the points.
Yes.
What did you say?
So here,
Line of nodes includes the
if you have this,
focus.
if this is your equatorial plane, okay? Can this be an orbit?
No.
It cannot be an orbit.
Yeah.
You get it?
Yeah.
Can this be an orbit?
Well, if you drop a pylon,
No.
what's drop a pylon?
I'm sorry, what is the horizontal arm supposed to be?
That's
Equatorial plane.
That's
So in order for it to be an orbit, it has to pass through that?
look, that's the middle of the earth. That's this. So it's got.
So if this is the, what is the line, what do we know about this line? So here, this orbit has to pass through that line, always.
So it's never been a satellite to orbit above the hemisphere, right?
Not only above hemisphere, it has to be above and below. You got it? It cannot just do that. It cannot be like a hat. It cannot be like a hat sitting on Earth. You see that? It cannot do that just on the northern hemisphere. It has to do that. It has to do this. It has to do this. It has to pass the equator at some point. There cannot be an orbit which will not pass through the equator. Can there be an orbit which will not pass through the hemispheres? Through the North Pole or the South Pole?
Yes.
Yes. But there cannot be an orbit which will not pass through. Even the polar orbit will always pass through the equator. You got it? Now, this is called the line of nodes. Alright? Make sense?
Yes.
Now, if you see, what is the direction of Earth's rotation here? How do you identify the Earth's rotation direction?
The arrow.
Huh?
You see America?
Huh?
The rotation of the satellite.
So we know that it's turning this way. Counterclockwise.
I think just look at the arrow.
See, counterclockwise, clockwise, it's a perspective, right?
But you can look at theta.
If you look from the top, it is
Counterclockwise.
counterclockwise. If you look from the bottom,
Clockwise.
clockwise. Can you perfectly describe which has no ambiguity, can you define the rotation of Earth? I have shown you, I have actually indicated this to you. We have discussed this several times. If this is the north direction, okay, you move your fingers like this, curl your fingers, that is the direction of Earth's rotation. This will not go wrong. There is no ambiguity in this. Right hand. If this is the north direction, the Earth has to rotate like this. You get it?
Yeah.
So here, that Z is the
North.
north. Okay, that is the north direction. So this thing is rotating like this. Your Earth is rotating like this. Okay. Similarly, the H. You see the H?
Yes.
H will tell you how the satellite is rotating. You get it? If this is that H, the satellite is going this way.
So it's just like a plane vector.
Huh?
It's just like a
It's the plane
What
vector.
do you
Yes.
think?
If this is the north direction, Earth is rotating like this.
Right.
And here, if it is whatever the orbit, if you want to know the orbit by its, if you want to know the direction of Earth's, the orbiting body, if you given a shape or given a plane, let's say this is the plane, okay? The satellite could be rotating like this or this.
They'll go with her.
Huh?
They'll go with her to stay.
Not necessarily.
You can, but it'll,
I mean-
you said the orbit will be decreased if it goes against the orbit.
Yes, so there are prograde orbits and there are retrograde orbits. Okay? So it depends on how you launch it. But how do you identify or define the direction of that orbiting? Again, right hand rule. Okay? If you just do this, this is the H direction. This will tell you which direction the orbiting body is going.
Oh, I see what you're saying.
So here the orbiting body is rotating or orbiting this way. You see that? The direction is identified here. You see that arrow? Where is that arrow?
It's at the top.
It is not.
Right. V0, you see that V0, that arrow is there. It's telling you how that orbiting body is going. Considering that is the orbiting direction, you see there are line of nodes. Line of nodes means there has to be at least 2 nodes. Agree? What is a node? Node is a point. You see that? So this point is the ascending node. Guys, see that. Don't look at your cell phones. You'll lose this. You will, if you don't understand this, you will lose the rest of the lecture, rest of the half of your semester. So pay attention to it. This is the ascending node. You understand why is that ascending node?
It's coming up.
Huh?
What you said the node again?
Node is a point.
It's the point where the satellite intersects the orbit. I mean, the 2 planets. So it's-
Why is that the ascending node? Correct. What is happening there?
It's coming up. It's
Coming up off?
above the equator.
Yes. It's ascending from the equator.
So the other side would be the descending.
Huh?
So the other side would be the descending.
The other side will be descending.
Wait, hold
Like
on.
the other side on the other side of the earth.
On the other side of the earth.
Yes.
Right, so that node is going forward, not down.
The node itself is not going anywhere.
Why is there an arrow?
The orbiting body is going. Orbiting bodies has to do this, right? From that point forward, it is going up. It is climbing up of the equator. Does that make sense? If you look at this,
You talking about the red line or the blue line?
so you see this, that red dot,
Yeah,
that is going like this.
yeah, that makes sense.
Okay? That keeps going around the path. When it is here, it is going up like this, right? It is going up from the equator. Equator is like this, right?
Yeah.
The satellite is doing like this. So it will come here, so look at this. So this is the equatorial plane. Satellite is doing like this. At this point, it is ascending. That node is called the ascending node. This node will be called descending node. It's going below the equator. Okay. So that is the ascending node, and now let's look at the various orbital parameters. Okay. You have already looked at. You should already see at least 2 or 3 parameters. What is the first parameter? Or element? Orbital element. What is the first orbital element we talked about?
Angular velocity, angular momentum.
Yes, angular momentum is also an element, but what did we discuss here? Anybody? The first element we discussed.
R.
Size of the orbit?
The size of the orbit. The size of the orbit, I told you this, H also defines the size of the orbit. Okay? But strictly speaking, A, you know what A is now. What is A?
Area.
Huh? Come on guys, what is A?
Size.
A is size of the orbit.
Semi-major axis.
Oh,
You just took the test.
Wait. You didn't say you meant that concept.
Huh?
Never mind.
You just took the test, right? I gave you what is 2A. What is? Can you indicate 2A here?
Yeah,
Yes.
Indicate 2A.
it's the x-axis. It's the x-axis. You said. Oh, hold on, no, y'all finna try. 2A equals is this. It's the major axis.
Indicate 2A. Yes.
This is x.
Come on, yeah, go ahead. You can reach it. Indicate 2A.
This is 2A, right?
The fact that we can reach.
This is A. This is A. And this
Is that A?
plus that. This is A.
You sure?
Come on, man. And on this plane, this is
What plane is 2A?
the equatorial plane. The plane of the equator. This gray piece right here. It's not. This is the major axis.
It's not.
That's not the major axis.
Come
Why is
on,
mine-
Jamal, indicate the, help him out.
Come on, man.
Huh?
Well, we learned about the Earth orbit. We learned about the satellite orbit. So A and R.
A is not R, but what is A here?
It's A-E.
Huh?
E.
What
The E was going E.
No, you know what 2A is. 2A is.
So we're not doing the Earth's orbit.
Alright, just look at this. Now that is what I'm trying to get you guys to understand. Yes.
R plus RT.
Huh?
R plus RT.
No, but what is A here? Can you indicate A? That's what I'm trying to get you guys to.
A is a semi.
Or 2A. Here you cannot indicate A.
When 2A the line with the E.
Huh?
When 2A the line with the E. You see the line and the E on the line over? That's not 2A.
So we need R to find
It would be the whole what?
where you should be.
From
So
the satellite's position, that's the direction of
Right?
So here A would if you really wanted A, it would be 2A from this point. You see, this is the orbit.
I thought
It will
you
be
were
from
talking
this-
about Earth.
I get it.
Also, it's
No,
for
this
the
is
working
for the
light.
satellite.
I thought you were talking about Earth. I thought you were saying looking
Yeah.
at the Earth would see.
There is no 2A for Earth itself.
Okay, so then it pretty much just tilts. So just tilt it to the right. If this is R, no, seriously, if this is R, then that's your semi-major axis. I mean, this your major axis. What, like R? Just draw a smooth line all the way through there.
Yes. So you see, yes. So if you look at the top view, this is what I've been teaching you. Okay, look at this. You see this? This is the orbit I've been drawing, or you guys have been drawing. Okay, so this is that distance.
Scroll down some.
So which one of those lines right here is the main?
If I got anything, bro, I got that.
Dr. Lim, which line on that picture down there is one of those lines, the semi-major axis?
You see? Can you make out A now?
Yeah.
What is 2A? Now you see why?
That was the line with the E.
Huh? No, that is not the line you indicated.
No, the line with the E. Did the E say that at the end of it?
Nah, the E was not.
I asked you, it's not. Again, 2A is not a line. Okay, 2A is a.
Plane.
Axis.
Plane. Axis.
It's a distance.
Oh yeah.
You cannot just say 2A is this line.
It's the distance from. Okay.
You understand?
Right.
What is that line called?
The major axis
What line?
Again, major axis is what?
is 2A.
2A. What is that line called?
One.
The line she is talking about?
Oh, you start with an A.
Yes.
Apps.
Apps line.
Yeah.
See, apps line is a line. 2A is a distance. Okay?
Oh gosh.
You got it? So here, if you look at that 2A, so this is the top view. Okay? Top view of, this is what we have been drawing. What is here? What is here? What is this?
Occupied focus.
Occupied focus. Okay? This is the core. This is the center of the earth. You got it? So this is that distance. This is, what is this point?
That is the P1. That's your closest point.
Oh, that's the ascending node.
That is the ascending node. What is this point?
Wait, what does that mean? You said ascending node?
Huh?
Periaxis.
Periaxis or the perigee. Why is this the ascending node?
What does
Because
that
it's
mean?
coming up from above.
Huh?
It's coming up.
It's coming up. Yes. So if you see, huh?
What does that mean? You said ascending node?
Ascending node. So there are two nodes, right?
I missed that.
You don't know.
It's very, very important. There is the line of nodes.
Keep using the bottom picture.
Okay. So this is the line of nodes, and this point is the
Ascending node.
ascending node, and that is that point I showed you just now. That is the ascending node. You get it? Okay.
Because it approaches the line of nodes.
Huh?
It's ascending node because it's.
Why is it ascending node?
Because it's coming up.
There are two nodes, right? This is one of the nodes, okay, and that is the other node. At this point, the satellite is ascending; it's climbing up from the equator,
Okay,
equatorial plane. So that is the reason this is called ascending node. That is the descending node.
understood.
Okay. Now, so you have, we define, you know what z direction is, right? What is z direction?
It's goes the act. It's the
What is it? Z direction? Axis of rotation. Okay. Now, similarly, we define this x direction as, you know what the sign is?
Orbital equinox.
Huh?
Gamma.
What is the sign?
I can't see.
This sign is Aries. You know what Aries is?
It's Aries. It's what?
Aries.
Oh, Aries, I'm so
Huh?
excited.
There are, how many constellations are there?
That's exactly what they do.
Okay.
How many constellations are there? There are millions of constellations, but we, for the sake of our these things, we consider around the equator there are 12 constellations which we focus on, right? Which this is that Aries constellation. Got it?
So we use that to.
That as a reference of x direction. Okay? That Aries constellation on the first day of spring, the line joining the center of Earth and the Aries constellation is that x-axis.
So it's a certain point in Earth's orbit around the sun that we.
Right. So once we define this x direction, we can conveniently define all the other angles with respect to that direction. You get it? Yes.
What did you say about that? It's the line on the sun.
So the Aries direction, see all these 12 constellations are around the equator.
Right,
Okay. There are millions of other constellations.
right.
What is a constellation? An arrangement of stars. Does this have to be predefined?
Yes.
Can you form your own constellation?
Yes.
You can form your own constellation, right?
Yeah.
So you can come up with your own constellations. But what we know or what we standardize are these 12 constellations around equator. So the 12 constellations are nicely placed around the equator. We know the direction of those constellations. So the line joining the center of the Earth and this Aries constellation on the first day of
I see what you're saying.
on the first
So that line, okay, it makes sense.
that line is this line.
It's joining the center to the, okay, I see what
Got it? So if you're seeing, it will tell you that this is that line. If you stand like this, and if your sight goes towards, if you're at the core of the Earth, and you're looking at the Aries direction,
Okay.
that is this on the first day of spring. Okay. What is the first day of spring? Equinox or solstice? Equinox. So what are the 4 days
What are the 4 days?
which define your
Solstice, vernal equinox, autumn
vernal equinox? That is on the first day of equinox. That is the reason this is called Equinox. On the first day of equinox, or first day of spring is the vernal equinox. Then you have the
Solstice.
summer solstice, right? Then you have the
Autumn.
autumnal equinox.
Fall. So the winter solstice.
There is no fall equinox. Okay?
Fall solstice.
All time.
There is no fall solstice either. You'll be fined for that.
Fall.
Huh?
Like, say,
Wait,
what
what?
That's here.
So you have vernal equinox. What is vernal equinox?
Spring. That's
That's the first day.
What is spring? So what is what is equinox? You know what an equinox is?
The hemispheres are the same distance from the sun.
Yes. So the equinox is when you have equal amount of daytime, equal amount of nighttime. That's the reason it's called equinox.
Okay.
Summer solstice. The day is the
Longest.
largest. Yes, longest. That is the solstice. Then you have the
Autumn.
autumnal equinox. Again,
Autumnal?
Huh?
How do you say it again?
autumnal. So it's the season of autumn. Autumn season, here in the US it is called the fall season. Don't be limited in your vision or limited in your understanding. In the rest of the world, or at least, let's say not rest of the world, but all this was, a lot of this happened in the erstwhile, not even Greek, it's, although a lot of things happened in the Greek, this thing, Newton, where was Newton from? England. So a lot of this happened in England, in the European countries. Because in the 16th century, did an US exist?
No.
There was no US, right? So autumnal comes from the season of autumn. Autumn is nothing but
Fall.
fall. So there's autumnal equinox. And then there is
Winter solstice.
winter solstice. Okay?
The shortest day.
That winter solstice is the shortest day. That is when your time change happens, right? That is around winter solstice.
You said winter solstice?
Winter solstice.
Solstice.
So there are two solstices, there are two equinoxes. Now this is on the first day of equinox, the line joining the center of the earth and the Aries constellation is the X direction. Okay. So now what we do is we have already defined shape, we have already defined size, right? If A is bigger, what happens? If A is bigger, does anything happen to this plane?
No.
No, it is the same plane. Okay. If A is bigger, what happens?
Then the orbit changes.
This becomes
Larger.
larger or smaller. Got it? Make sense? Okay. E, what does E tell you? The shape, right? Here, what is the shape? It's an ellipse. It's an elliptical shape. Okay. So now you guys can, if I pull it down, you can see that that's an ellipse. Okay. So here you know it's an ellipse. What is theta? Can you identify the perigee direction here?
Yes.
It's written right there, right? So can you identify theta or the true anomaly?
Yeah.
What is true anomaly here? Where is the satellite? Where is the satellite right now?
It's right there.
That red thing is the satellite.
Right.
Okay. So what is the true anomaly?
So would
The
it be something
V9,
or
like where the V9 is.
Parity and
There you go.
satellite position.
No, it's coming from the perigee line.
It's always from the perigee line.
Oh,
But to that point you went to.
Here, this angle
Right.
is that theta. So there are three orbital elements. Okay. Now, what I want you to look at is there are three more elements here. Okay. This is first of those other three elements. This cap omega is called the right ascension of ascending node.
What's that again?
Right ascension of ascending node.
It's indicated if you become a space engineer, they'll tell you RAN direction. What is right ascension of ascending node? You see that?
Is that an angle?
It's an angle. Okay? Right ascension. Why is it right ascension?
Because it's on the same side.
So if you look at this, it is ascending in the right sense. You see?
Oh, okay. What you're saying.
You see that?
Yeah.
Of the ascending node. How far is the ascending node, or what is the angle of this line of nodes, ascending node, from this x direction? Okay? How much is the angle to it? How much is the orbit tilted? You see that? So what happens if you change this orbit like this? That may change, right? That line of node may change. So you want to figure out what is the line of node, or what is this ascending node? Where is that ascending node with respect to this x direction? What is the angle? It's the angle essentially. Okay? The next one is, what plane is this angle in?
The omega.
Cap omega. Equatorial plane, yes. That's a good observation. So if you see this plane, this angle is in the equatorial plane. Okay. This next one is the small omega. Small omega is called the argument of perigee. Okay. Perigee, or argument of periapsis. It tells you how much is the angle between this line of nodes and the perigee direction, or periapsis direction. You see that?
Okay.
In what plane is this angle?
The orbital.
Orbital plane. Okay. The other one, which is the most important, is the inclination of the. Now, I is that inclination. Okay. Inclination. What is the inclination? Inclination is, what is the inclination of this with respect to the surface?
It's the slant, like the tilt.
The slant, right? This, can I say it is, okay, can I say it is, if this is that, this thing, can I say this is the inclination?
Yes.
Can I say this is that angle?
Yes.
We can say that, right? Instead of doing this, what we do is, we draw perpendiculars to both these planes. Okay, this plane and this plane. And you can just see that the inclination between the perpendiculars is the inclination between the planes as well.
Okay.
Makes sense? The angle between the perpendicular to planes is the angle between the planes. Does that make sense?
Yes.
So that angle, what does this plane, this z-axis define? Which plane does it define? Equatorial plane. What does h direction define? Orbital plane. So the angle between that will define the inclination between the two planes.
So that's I.
That's the I.
So little I and omega. Little omega, that's the same thing.
No, that is not the same thing. So this is that I is the angle between those two, right? Omega is the angle between the line of nodes and the perigee direction. Got it? How do you, in reality, how is perigee, now that's a good point. How is a perigee direction formed? How do you think is a perigee direction formed?
I was going to ask that.
Yes. Tell me.
I don't understand.
So how is it formed?
Yeah, what is that perigee direction?
I don't know.
It's when you first enter orbit.
Yes, exactly. So when you first enter the orbit, right, and then you start doing that, that is the perigee direction.
Okay.
You get it? That becomes the perigee direction. You fire, you go like this, right? You release your satellite and then you fire your this thing. That becomes a perigee direction.
So that's you're saying direction, but you're describing it as a point.
But that the direction. So this is always predefined, right? This is the center of the Earth is predefined.
Yes.
So if you're flying something from the US, you fly, let's say like this, and then you fire your thrusters to go like this.
Yes.
That will become the perigee direction. So the line joining whatever point you fire your thrusters, you join that point in the center of Earth. Center of Earth is always defined.
Yes.
That becomes the perigee direction.
Okay. Understood. Okay.
Okay? So do you understand these 6 elements?
Yes. So why would the perigee direction be useful for anything?
It's the closest point of closest approach.
You said it's the closest point, so it's also the peri.
So perigee means periapsis is a point of closest approach for any 2 bodies in general.
Yes.
When we talk about perigee, the central body is Earth.
Okay.
You get it?
Oh, that makes sense.
Perigee. G stands for geo.
Yeah.
So if the central body is Sun, periapsis becomes
Perihelion.
perihelion. Okay? So the central body is what makes it a specific term. Perigee, perihelion, periapsis is the general. Got it? So I want you to familiarize yourself with these orbital elements. You will be again required to draw, identify these orbital elements as part of your next exam. A lot of your next exam, not the next midterm retake, but a lot of your next exam will revolve around this orbital element. I want you to clearly understand what these 6 orbital elements are. Again, what are the 6 orbital elements?
Omega,
You start with
So,
size, shape,
orientation.
orientation. 3 angles will define orientation. Cap omega, small omega,
what's it?
I.
You said cows?
Cap omega, the big omega. Cap omega, small omega, I. Together form the orientation. Then the theta. Here it is B. Okay? Or it is
Dr. Sandy, the W is smaller than you, right?
W is the small omega.
That's the argument of
Perigee. Yes. So that is the argument of perigee. Cap omega is the right ascension of ascending node, or RAM. RAM.
That's the difference between.
It's not the distance. All these 3 are angles.
Angle in between the Aries and the line of nodes.
Yes. So you have the angle between Aries and line of nodes is in the equatorial plane. The angle between line of nodes and perigee direction is in the orbital plane. Yes.
So is small omega, is that an angle or is that a point?
Angle.
So how is that angle not equal to I? How is that different?
Because it does not define. See, angle is between 2 planes, right? Or if you look at omega, it is only in 1 plane, small omega. But I is between 2 planes.
Okay.
I is with reference to the equator and the orbital plane,
Okay.
right? But omega, small omega, is simply in the orbital plane.
Okay.
You see that? It's the angle between 2 lines in the orbital plane. The equatorial plane does not come into play at all when you're talking about small omega.
So that line right there, that's equator, and small omega is
Right. So this direction is what?
the equator. No.
Equator is this.
Okay.
Okay. So here, so this angle is what?
Small omega.
Huh?
Argument of Perigee.
It's the small omega, yes. So it's in this plane. This is the orbital plane. Okay. But your cap omega is between, I is between 2 planes.
Okay.
It's very different. Okay. So if you change this, let's say if you change the plane, the orbital plane, this may not change. This may remain the same. I will definitely change. Okay. I will tell you how inclined it is with respect to equator. So I will tell you if I is 90, what does that tell you?
That is the polar orbit.
Polar orbit. You get it? If I is 0, hang on. If I is 0, anybody else?
Zero.
Come on. Huh?
It's in the same place.
Yes, what is that orbit?
Circular.
Equatorial orbit. Yes.
Wow. Can you scroll up? I see.
Jalil, explain to them why if I is 90, it's a polar orbit. So with respect to the equator, okay?
That's zero.
Right, so if with respect to equator,
Yeah, that's right.
okay, if this is your equator, and they'll say this is my orbital plane. If it is like this,
It's revolving around the equator.
it's doing this.
Around the poles.
So the angle is this, 90 degrees. You see that? What is it?
The angle of I is 90 degrees?
Mm-hmm.
Wouldn't that mean, okay, yes.
That means it'll be rotating around the poles.
Get it? No?
Yes.
Some of it, I really don't. I don't know why it's or 90 degrees is certain on the ball.
If this,
That right now.
Yeah, I know, but like, what is that?
If this move, this H, as I move H, this orbit moves. So if I tilt this all the way here, that's going to tilt all the way there.
yes.
That is perfect.
Like we have like
The z direction, will the z direction change? No. Right? Only that I direction will change. If right now this I is like this, right? It means your orbit is like this. If your I has to be like this, right? It has to become that. That will become 90 degrees. Now similarly, your 0 degrees is when your orbit becomes parallel to the equator. That will become the equatorial orbit. Okay, then I is equal to 0. You see the difference between I and omega?
Absolutely.
So omega is simply the angle in that orbital plane itself.
Okay, so when it comes to determining I, do we always consider the direction of the orbit?
Yes, so direction of orbit is absolutely very important. So here, if the orbiting body was going the other way, you will look at the other direction. The H will go in the other direction.
It's like plus 180.
Plus 180, yes. Plus or minus 180. The Z will not change,
Right.
obviously, right? But your this thing will become
In the opposite
opposite.
direction.
So now the angle will become that. Now keep in mind the direction of the angle. Okay, it is like this. So it will be plus 180. That I plus 180 if the satellite was going in the opposite direction.
Counterclockwise direction.
Okay, all right. So we'll meet again on Monday.